Welcome back to The Explainer. Today, we're diving into a vulnerability that's been a classic thorn in the side of the web for, well, decades. We're talking about cross-site scripting, or as you'll usually see it, XSS.
So here's our game plan. We're going to start by really getting to know our enemy. What even is XSS? Then we'll look at the three main ways it shows up in the wild. And finally, the most important part, we'll talk about how to build up our defenses against it.
Let's just kick things off with a question that gets right to the heart of the matter. Is it possible for a website that you trust, a site you visit every single day, to be turned into a weapon against you?
And the answer is a huge, resounding yes. See, with cross-site scripting, an attacker doesn't have to break into a server. No, it's way cleverer than that. They just trick your web browser into running malicious code that looks like it's coming from a site you trust. It's a pretty slick deception that all happens right there on your own machine.
So you're probably wondering, how on earth is that even possible? Well, it all boils down to one single fundamental failure. A website takes something a user typed in, like a search term or a comment, and then puts it back on the page without cleaning it or sanitizing it first. It completely fails to strip out what could be dangerous code. And this basically gives us a treasure map of where these vulnerabilities are hiding. Just think about any place on the web where you see content that other users have posted. We're talking forums, message boards, comment sections, even the results page for a search you just ran. If that website isn't super careful, any one of those spots can become a launchpad for an attack.
All right, first up, let's talk about the reflected attack. I like to think of this one as a trick mirror, because the bad script literally gets bounced or reflected off the web server and sent straight back to a specific victim. So here's how it goes down. The attacker creates a special link, a URL, with some malicious code hidden inside it. Then they trick you into clicking that link. Maybe it comes in a phishing email or a shady social media message. Your browser sends that request to the website server, which doesn't see anything wrong, so it includes that malicious code in the page it sends right back to you. And boom, your browser just runs the script, totally convinced it's a legitimate part of the site.
So the big thing to remember here is that this is a one-and-done kind of attack. The malicious code is never actually saved on the website. It only exists for the person who clicked that one specific crafted link. That's what makes it so tough to spot. It's often completely invisible to the site's security team.
Okay, now for our second type, and this one is way more dangerous. A stored attack isn't like a trick mirror. It's more like a digital landmine that's been planted on a website, just waiting for unsuspecting visitors to step on it.
With this one, the attacker finds a weak spot, say a comment section, and injects their nasty script right there. The website, not knowing any better, saves that script directly into its database. And from that point on, every single person who visits that page gets served that malicious code, and it runs automatically in their browser.
And that's exactly what makes it so much more potent. A reflected attack has to trick each victim, one by one, but a stored attack, with one single injection, an attacker can hit thousands or even millions of users automatically. No one even has to click a special link.
All right, our last type is probably the most subtle of them all. A DOM-based attack is a kind of betrayal, where a website's own legitimate code gets twisted and turned against it, and the whole thing happens right inside your browser.
Now in this case, the server itself could be perfectly secure. The attack is actually exploiting a flaw in the JavaScript that's already running on the web page. The attacker feeds some malicious data to this script, which then causes it to incorrectly change the page's structure, what developers call the document object model, or the DOM. You can think of the DOM as the live interactive blueprint of the website inside your browser, and by manipulating that blueprint, the attacker can execute their code.
And here's the really scary part. Because the entire attack plays out inside the user's browser, the website's server logs might show absolutely nothing unusual. This makes DOM-based attacks incredibly stealthy and just brutally difficult to detect.
Okay, so let's do a quick recap. Reflected attacks are temporary, and they live inside a URL. Stored attacks are persistent. They're hiding out in the website's database. And DOM-based attacks, well, they're also temporary, but they work by messing with the code that's already running on your machine.
All right, enough about the problem. We understand the threats. Now for the most important question. How do we build the digital shield? How do we actually defend against these things?
Well, our defense strategy really rests on three main pillars.
First, input validation. You have to be incredibly strict about checking all incoming data and just reject anything that looks even a little bit suspicious. Second, and this one is crucial, is output encoding. This just means you take any user content and basically wrap it in digital quotation marks, telling the browser, hey, display this as text, but do not execute it as code. And finally, you use a content security policy, or CSP, which is kind of like a bouncer for your website. It gives the browser a very strict guest list of approved, trustworthy sources for scripts.
You know, all of these defenses, they're all built on one simple, incredibly powerful idea: zero trust. The absolute golden rule is to treat every single piece of data that comes from a user as if it's hostile until you have proven without a doubt that it's safe.
And that kind of leaves us with one final and pretty challenging thought. The web as we know it is built on user content, on interaction. But every input field, every comment box, is a potential doorway for an attacker. So finding that perfect balance between creating a fun, engaging, interactive experience and maintaining rock-solid security, well, that's the ongoing challenge for every single web developer out there.